Describe the translation from y equals x squared. Sketch the two graphs. So the y equals x squared graph has the vertex on the origin. If I was to sub in x equals 1, 1 squared is 1. And if I was to sub in x equals negative 1, I would also get 1. So there's a very quick little sketch of y equals x squared. The other parabola that I've been given, y equals x squared plus 6x minus 7, it tells me that I need to complete the square. So I take the first two terms, the 6 in front of that x I need to halve and square, so half of 6 is 3 and 3 squared is 9. I add 9 on and straight away take it off again. And I also still have the negative 7 on the end. The first three terms will then factorize to be a perfect square. Halving the 6, it will become x plus 3 all squared. Minus 9 minus 7 is negative 16. So there's my equation factorized into turning point form, which means that I can read off the turning point. The brackets tell me the x coordinate. The opposite of a plus 3 is minus 3. And the negative 16 on the end is the y value of the turning point. To describe the translation, like the question asks me to do, that means that my parabola has been moved left, because it's gone to the negative side, left 3 spaces, and it's gone down to negative 16, which means it's down 16 places. So on my Cartesian plane over here, I'm going to have a vertex at negative 3, negative 16, which I'm going to put down here. But to draw the rest of that parabola, I need to know some intercepts. So I'm going to need to sub in when x equals 0. Now, the easiest place to sub that into to get a quick answer is to sub it into this original equation up here, because x squared plus 6x, both of them have x in them, making it 0. So the minus 7 on the end would be the intercept. So y equals negative 7. Let's put that over here. To find the x-intercepts, I sub in when y equals 0. For this one, I will use my factorized by completing the square formula. So y is 0, x plus 3 squared, take away 16. Move the 16 to the other side. Square root to get rid of the squared, which means plus or minus 4. And then finally move the 3 across to the other side. So minus 3. That will give me two solutions. 4 minus 3 is 1, or minus 4 minus 3 is negative 7. So x equals 1 is marked on my graph already, and let's put negative 7 down here. So my parabola is going to come up through both of those intercepts and the minus 7 as well. Question 4b is a slightly harder version of that. We still want to complete the square on y equals minus 2x squared plus 4. And we want to describe the translation from y equals x squared. So let's start by doing our quick sketch of y equals x squared again. So the vertex is on the origin at x equals 1, y equals 1, and when x equals negative 1, y equals 1. There it is. Then, for the second equation, we had y equals minus 2x squared plus 4x. To complete the square, we don't like to have a number in front of our x squared. So let's factorize out a minus 2 giving x squared. When I do 4 divided by minus 2, I'll get minus 2x in the bracket. Divide the negative 2 across to the other side so that I have the start of my quadratic ready. So I have x squared minus 2x. To make the perfect square, I halve the minus 2, which is negative 1, and square it to get a 1. I straight away subtract that 1 off again. Next, I factorize those first 3 terms to be y over negative 2. The perfect square that it makes, you halve that minus 2 again to be minus 1. So it'll be x minus 1 in brackets squared minus 1. Then I want to get the y back by itself, so I'm going to times the minus 2 across to the other side again. So that'll be minus 2 times by the x minus 1 squared. Minus 2 times minus 1 makes a plus 2. So we can now read off our turning point. The x value comes from my bracket here. It's the opposite of minus 1, which is 1. And the y value comes from the number on the end, which is the 2. The 2 that is in front of that bracket doesn't do anything for the turning point, but it does tell me some other things about the graph. The minus sign tells me that the graph has been reflected or turned upside down. The 2 in front of that bracket tells me that the parabola is going to be made steeper, and the turning point itself told me that the parabola had been moved 1 space to the right, so it's been moved right 1, and the y value of 2 means it's been moved up 2. So I can plot my turning point, which is at 1, 2, and I know it's going to be coming concave down back towards that x-axis, but I need to find out where it's going to intersect. So I'm going to have to sub in when x is 0 and when y is 0. Starting with when x equals 0. If x equals 0 and I put that back into my original equation up here, the first term will be 0, the second term will be 0. I would just get that y is equal to 0. Then if I sub in y is equal to 0 into my equation, now because I'm trying to find the x values here, it'll probably be easier to use this version of the equation to sub into. That would be 0 equals minus 2 bracket x minus 1 squared plus 2. Move that whole first term across to the other side, which will make a positive 2 x minus 1 squared equals 2. Divide both sides by 2, which gives me a 1. Square root to get rid of that squared, so the square root of 1 is still 1, but we'll have a plus or minus in front of it, and move the negative 1 to the other side, making it a plus 1. So positive 1 plus 1 is 2, negative 1 plus 1 is 0. So 0 we kind of already would have known from this thing that we worked out before. So we knew that we were going to have this intercept, but we now also know that there is another one here at 2, and so we can draw our parabola. And question 5. It says to complete the square in x and in y on x squared plus y squared minus 8x plus 6y plus 9 equals 0, sketch the circle clearly stating the center and radius. So I'm going to rewrite that equation, putting the x terms together, which will be x squared minus 8x, and the y terms together, y squared plus 6y, and the 9 on the end, equals 0. Now, taking the first two x terms, I want to make a perfect square. So I halve the 8, which is minus 4, and square it will be a plus 16. I'm going to have to subtract that 16 off again. Then I take the y squared plus 6y, take the 6, halve it and square it. So half is 3, 3 squared is 9. Take the 9 straight off again, and I still have the 9 that should be on the end of my equation. Now the first 3 terms make a perfect square. It's x minus 4 in brackets squared, just halving that 8. These three terms here will factorize to be a perfect square as well. Halving that 6, it would be y plus 3 in brackets squared. The minus 9 plus 9 will cancel out, but I do have this negative 16 still sitting in there. However, I'm going to move it to the right hand side of my equation, because that's where I'm used to seeing the radius of my circle. So now that I've got everything factorized nicely, I can read off that the center of my circle is at, now using the x bracket, the opposite of minus 4 will give me an x value of positive 4. And from the y bracket, the y value will be the opposite, which is negative 3. The radius comes from the 16. We square root 16 to find the radius is 4. So we can draw that. We need to put a few measurements on here so we can draw our circle. Our center is at 4 minus 3. So 1, 2, 3, 4 minus 3 would be there. Label it. Now, to do the radius of 4, we count from the center. So from that center spot, I'm going to go 4 spaces up. So 1, 2, 3, 4 spaces up would be here. 4 spaces down, 1, 2, 3, 4, which would be at negative 7, and that one there is at 1. I'm going to go 4 spaces to the left, 1, 2, 3, 4, which puts me right on the axes, and 4 spaces to the right, 1, 2, 3, 4, which will put me at 8. So I can connect that up as best I can to make a circle. I've already got my y-intercept, but I could find my x-intercepts. So my y-intercept was at negative 3 here. My x-intercepts I need to find by subbing in when y equals 0. Now I'm going to put that into the original equation. You could do it into the, actually let's put it into this one. Let's put it into there. So that's going to be x minus 4 in brackets squared plus y is 0, so 0 plus 3 in brackets squared equals 16. So x minus 4 squared, let's leave that for a minute, but 3 squared is 9, and that's equal to 16. If I subtract the 9 across to the other side, 16 take away 9 is equal to 7. Then I can square root both sides to get x take away 4 equals plus or minus the square root of 7. And finally, I can add 4 across to the other side to get rid of that 4. So plus 4. When you type that into your calculator, if you type in square root of 7 plus 4, you're going to get 6.6, or minus square root of 7 plus 4 will give you 1.4. So they are my intercepts. Now my graph isn't very well to scale here because if I redraw that now, that should be going through 1.4, which should be about here, and 6.6, so 1, 2, 3, 4, 5, 6.6 would be about there. So that means I can show my intercepts more accurately. And there it is. Okay, now you can work on exercise 4A.